Now let's look at some basic operators in Python. Operators basically help us do basic arithmetic and logical operations. We'll look at a bunch of operators. And let's say if I say 2 plus 3, this is called an operator. And the operator is operating on 2 and 3, right? So these are called operands. These are called operands, right? This is called an operator, and both 2 and 3 are called operands. Just to get the terminology here, right? Okay, having said that, let's go and look at a bunch of examples, right? So we have all these arithmetic operators. We'll go and see what each of them are. I would prefer to execute some of this just to show you. So imagine if so this is assigning 10 to x and 20 to y, and I can just say this is simple addition as you would expect. I can of course do subtraction, very simple, straightforward. Again, of course, 10 minus 20 is minus 10. As you can see the output here, this is, let me just highlight the output for you. This is where the output is, just FYI. Next, if I can of course do simple multiplication, ding dong ding, straightforward, and of course division. Of course, 10 by 20 is half. Here is an interesting operation. I'll just not use the same things here. Suppose if I have 15 percentile 2, right? This is your percentage symbol. So what it does is, so for those of you who do not know what this percentage operator is, it's also called a modulo operator. What it does is, it divides 15 by 2. So 2 sevens are 14. It gives you the remainder that you get, which is 1 in this case. And that's what is the output of 15 modulo 2. It's nothing but what is the remainder that you get when you divide 15 by 2. Those of you who have some familiarity with any programming language would immediately recognize this. Okay. The next thing is a floor operator. For example, if I just say double, if I do double division symbol instead of using a single division symbol. Okay, let's do 15 by 2. 15 by 2 is 7.5. So what is floor? Floor basically is if I have any real value. So 15 by 2 is 7.5. Floor of 7.5, mathematically it's often written as this. Floor of 7.5 is basically the integer which is closest to 7.5 and less than 7.5. So on the number scale, if this is your 7.5, this is your 8, and this is your 7, the closest integer to 7.5 is 7, and it should be less than 7.5. So you get 7. That's what you got here as an output, right? This is what floor division means. Now the next interesting question is, what happens to floor division if I do minus 15 floor division 2, right? So this is interesting. This is a fun hack, because what is minus 15 by 2? Minus 15 by 2 is minus 7.5. On my number line, here is my minus 7 point, minus, of course, here is my 0, here is my minus 7, here is my minus 8. Right? In floor operation, what should happen is you should find a number, an integer, could be negative integer, which is closest to my number, but still less than this. That's why you get minus 8 and not minus 7. Right? This is important when you're doing a floor operation. So the floor of minus 7.5 is not minus 7, it's minus 8. A lot of people get this wrong. So the other interesting operation is called exponent. So what is exponent? Exponent is basically x power y. So I can represent it with 2 stars. So 2 power 4. Any guesses? 16, right? So 2 power 36, 34. This will be harder. Of course, I couldn't have guessed it. Okay. So what it's doing is it's basically computing x. So if this is x and this is y, it's doing x power y. So if you have x star y, this is nothing but x power y, right? So we also have the exponent function, exponent operator in Python, very nicely and useful for us. Again, all these mathematical operators will come in extremely handy for us. Again, then we have all these basic logical operators. So of course, and what the output is basically Boolean, they give us Boolean outputs. For example, if I just run this snippet of code here, of course, a is 10, b is 20, and so is print a less than b. Of course, a is less than b, so it prints true here, right? We have your, this is your greater than operation, this is your less than operator, This is your double equal to. Is A equal to B? This is A not equal to B, greater than equal to, and less than equal to. If you have any familiarity with a basic mathematical comparison or any programming language, this is straightforward for most of you. Having said that, let's go to logical operators, which are fun, right? So you have your logical and logical OR. So what is a logical AND? So let me just give you a quick table here. So true and true is true, right? True and false is false. False and false is of course false, and false and true is false, right? Similarly, what about your OR table? Your OR table is, okay, true or true is true, true or false, same, false or true, both of them are true, only false and false is false. Okay, these are your simple logical operators that you would have learned in basic logic in your high school, and exactly that's what it does. So this logical AND is exactly like double ampersand in C. Your OR is like your double line in C. Not is exactly like that. Okay, so instead of using these symbols in Python, you can just explicitly call them out with names. Next comes a very interesting topic called bitwise operators. These are a little tricky. Only computer science folks typically understand what these bitwise operators are, but they're very, very straightforward. Let's go and understand. So A equals to 10, B equals to 4. So how is 10 represented in binary representation? So A equals to 10. So what is 10? 10 is, sorry, 10 is basically, you can write it as 2 power 3 plus 2 power 1, right? So this is 8 and this is 2, so that's 10. So this is 2 power 0, 2 power 1, 2 power 2, and 2 power 3, right? So 0 here because there is no value here, 1 here, 0 here, and 1 here. This is the Boolean representation or the binary representation of 10, right? Similarly, so this is what your 10 is represented in binary. What about 4, right? 4 can be represented as 0, 1, 0, 0 because 2 power 2 is 4, right? So this is how you represent it. Now when you say AND, this symbol is a single ampersand, right? When you do it, it does a bitwise AND. So 10 and 4 is, now you do, okay, 0 and 0 is 0, 1 and 0 is of course 0, 0 and 1 is 0, 1 and 0 is 0. So what you should get here as output, you should get 0 as output, and that's what you get. Sorry, that's what you get here, right? Similarly, what about OR? Let's just quickly see that. Okay, let's just quickly see OR here. So when you do OR, you get 14. Why? Because again, simply 10 or 4, 0 or 0 is 0, 1 or 0 is 1, 0 or 1 is 1, 1 and 0 is 1. And this is 14, right? Because 2 power 0, 2 power 1, 2 power 2, 2 power 3, 8 plus 4 plus 2, that's 14, right? Works out. Similarly, you can do all these operations like or not. Not basically does the exact, so basically not of 10 would just say, would just flip these into 0, 1, 0, 1. Right? So these are very simple bitwise operators. Those of you who have studied computer science or have any familiarity with programming languages will quickly understand this. Next comes the interesting assignment operators. Of course, we have seen equal to. So what does this do? It assigns the value of 10 to A. Right? Now comes the other interesting operations like plus equals to 10. So those of you who have seen C would easily understand this. Okay, let me scroll up a little. Okay, so A plus or equals to is nothing but, so this is nothing but A equals to A plus 10. So minus equal to is nothing but A equals to A minus 10. Star equal to is nothing but A equals to A multiplied by 10, and so on and so forth. We have seen the floor division, the modulo operator, exponent operator, etc. It's just exactly the same thing. So whenever you have plus and equal to, basically a basic operator and an equal to, this will just unroll it into this format. This is a more concise representation of this statement, except that there is not much difference here. Okay, so those of you who have some familiarity with C would recognize this immediately. So A plus or equal to 10 should be equal to 20 because A already has a value of 10 here. 10 plus 10 will be 20, right? So again, very, very basic stuff here. Now here comes an interesting thing called identity operators in Python. So there are two such operators. One of them is called is and other is called is not. Right? So let's say I assign a value of 5 to A. Similarly, I assign a value of 5 to B. Now if I say print A is B, surprisingly you'll get it true. Because what's happening internally is, I think we discussed this in one of our previous videos, there is a memory location where 5 is stored and A points to it and B also points to the same object, right? So when you say is A, is it true that A is B? Yes, of course it's true, and hence it prints it, right? Now, the same thing is not true for lists. So here if you look at it, I have a list L1, which is 1, 2, 3. I also have a list 1, 2, 3. Right? You might say, okay, probably this list 1, 2, 3 is being created in a memory location and both L1 and L2 are pointing to it. Right? No, this is not true. It's only true for variables like this, for numbers, or for simple variables, not for complex variables like your lists and dictionaries and tuples, more complex data structures. It's not true. Okay, so this returns false for you. What about strings? Even for strings, this is not the same. Even though it's the same string, I have S1 and S2. You might assume that AAIC is a string being created in memory, and S1 is pointing to it, and S2 is pointing to it. And that's true. That's exactly how strings work, right? Because here in this, okay, let's just go here. So I told you, right? Only for complex data types. So if I run this, I get true. I could say is not, then you get false, right? So even for strings, everything works just like your numbers there, your numbers up here. Okay, only for slightly more complex data types like list, tuples, etc. it doesn't work. There's another very interesting operators in Python called in and not in, which are called membership operators. Let's look at it. Suppose if I have a list LST with 4 numbers 1, 2, 3, 4, I could say 1 in list. If 1 is there in this list, it would return me true. That's what it does. Very, very useful, right? Because now you can say whether an element is there in a list or not, right? You can do this for strings, for lists, for tuples, dictionaries, sets, etc. So let's do another example, right? Let's say I have a dictionary here. This is a dictionary. This is my key 1, this is my value 1, this is my key 2, this is my value 2. So I can search in the keys very easily. If I say is print 1 in D, since 1 is present in the keys, it would print true. Let's go to this code snippet and see what happens if I say is A in D, right? It says false. I can only check in the keys, not in the values, right? Can I say 2 in D? Of course it's there. What about 3 in D? Of course 3 is not there, so it should return as false. So in dictionaries, the in operator is only used to check if a given value is in the keys, in the set of keys. Here this is K1, value 1, K2, value 2. It only works in the keys and not in values, right? That's a membership operator.